Hi all. So in this class we are going to discuss about what is antenna gain and how it is calculated and what is the importance of this gain. So gain is a fundamental parameter of the antenna and it corresponds to the ability of the antenna to either direct the radiated power of the antenna in a specific direction or efficiently receive the incoming power from a specific direction. So it is defined as the ratio of maximum radiation intensity of the test antenna to that of the reference antenna where the input power is the same. So gain is equal to maximum radiation intensity divided by maximum radiation intensity. Maximum radiation intensity is from test antenna and maximum radiation intensity is about reference antenna. So this means to determine the gain, the actual or test antenna is compared with the reference one. However, if we consider the directivity of the antenna, then it is defined as the maximum radiation intensity to the average radiation intensity of the ideal isotropic antenna. So directivity is equal to maximum radiation intensity divided by average radiation intensity. Hence, in directivity measurement, comparison between two antennas is not taken into consideration. So, the gain of an antenna with respect to an isotropic antenna is write as G naught equal to alpha into D. Here, G naught denotes the gain of an antenna with respect to an isotropic antenna, and D represents the directivity. And alpha is a constant that shows the effectiveness ratio whose value lies between 0 and 1. And it is to be noted here that in high frequency antennas the losses are considered to be negligible, thereby processing 100% efficiency. This alpha equal to 1, so the value of measured gain is almost equivalently to the directivity. And methods of antenna gain measurement. So, in the previous section we have seen that to determine the gain of actual antenna and a comparison from the reference antenna is required. So, there are various methods by which the measurement of antenna gain can be done. However, the use of the methods is categorized on the basis of frequency of operation. Suppose if the antenna is operating above 1 GHz, then its gain is measured by free space ranges. At low frequencies, as the wavelength is longer, so free space conditions will not be easily achievable. Thus, between zero point 0.1 to 1 GHz, ground reflection ranges are used. So, according to these two specific ranges, there are two standard methods are used for antenna gain measurement, that are gain transfer or direct comparison method or absolute gain method. So basically in free space range, the contributions from the surrounding environment of the system get suppressed, while reflection ranges generate constructive interference in the region of the practical antenna. Hence, this article will discuss how the gain of the antenna is measured using these methods. So, first one is direct comparison method. It is explained with a proper diagram. So, it's having primary antenna and secondary antenna and one standard gain antenna, and it is connected with variable attenuator, and the signal source and modulator is available, and the an indicator is available, and the detector is connected with power bridge. So we already discussed in the beginning that for a measurement of a gain, a comparison between two antennas is made. Thus the technique of the direct comparison is used. So in this method of gain measurement, a comparison between the signal strength of the unknown gain antenna and the standard gain antenna is made. Basically, the standard gain antenna is the one with the known gain. The standard antenna and the test antenna together form an arrangement of the primary antenna, while the secondary antenna in the arrangement is simply an arbitrary transmitting antenna with the unknown gain. This is clearly showed in the previous slide figure. It is to be kept in the mind that the considerable distance between the standard and the test antenna is maintained so as to avoid the chances of coupling or any type of interaction. Generally, an electromagnetic horn antenna is used as the standard gain antenna. Also, as discussed in the pattern measurement, that the distance requirement of the arrangement is such that r greater than or equal to 2d square by lambda. So, the distance between the primary and secondary antenna must be properly maintained. As standard and test antennas are acting as a unit, thus to have appropriate matching with the load. An attenuator pad is placed at the receiver input. So it is to be noted here that during the whole measurement, there must not be fluctuation in the frequency of the power radiated towards the primary antenna. So to ensure this, power level indicating device or power bridge is used at the transmitter. Let us see what procedure must be followed to determine the unknown gain through the direct comparison method. So these steps are explained below. So initially in the standard antenna with a known gain is connected to the receiver using the switch S, and it is directed towards the direction of maximal signal intensity of the transmitting antenna. With a properly applied input to the secondary antenna, reading of the receiver is noted. Along with this, the reading of the attenuator dial W1 and the power bridge P1 is also noted down. Now the switch is removed from the standard antenna, and with the help of the same switch connection of the test antenna is made with the receiver. Further, the reading of the attenuator dial is adjusted to get the same readings on the receiver as it was in the case with the standard antenna. So that the dial setting be W2 and the power bridge reading is P2. So the case 1 is P1 equal to P2, then gain of the test antenna will be Gp equal to W2 by W1. In decibels, Gp of dB equal to W2 of dB minus W1 of decibel. And in the case 2, if P1 not equal to P2, then the actual power gain of test antenna will be product of Gp and P1 by P2. So let P equal to P1 by P2 and G equal to Gp into P, and finally we will get G equal to G of dB equal to W2 of dB minus W1 of dB plus P of dB. This is the gain of the test antenna. In this way, by the comparison method, the gain of the antenna is determined. Then the next one is absolute gain method. Here one transmitting and receiving antenna is presented, and the attenuator pad, receiver detector, indicator and variable attenuator, and the detector is connected with power bridge, and one modulator is connected with the signal source. So in the previous section that the standard gain antenna is the one whose gain is already known as calibrated. However, we can calibrate the gain using 2 or 3 arbitrary antennas. So the figure represents the arrangement of 2 identical antennas for absolute gain measurement. Suppose the 2 antennas transmitting and receiving are separated at a distance R. Here PT and PR represents the transmitted and received power respectively. Okay. So while AET and AER are the effective aperture of transmitting and receiving antennas. As the 2 antennas are identical, therefore AET equal to AER equal to G0 into lambda square divided by 4 pi. By Friis transmission equation, the G0 value is calculated as 4 pi r by lambda root of PR by PT. While if we consider the effect of direct and indirect rays in case of ground reflection, then G0 value will be 4 pi t divided by lambda f root of PF divided by PT. So F is the propagation constant due to interference. From the above equation, it is clear that the power transmitted by the transmitter and the received by the receiver is measured. Then for the known value of separation distance or the wavelength, the gain of either antenna can be determined. Hence, in this way, by using any of the above described methods, the gain of the antenna can be measured.